Hi there guys, got a video here for you today and we're going to be making a moderator. Now this mod's going to go on the M3 and I just want to make it a little quieter. So I've pre-cut my stock and I thought I'd bring you along and I'll show you how I do them. Now these aren't for sale, this is just one I'm making for my personal rifle. So what we have here is the three components: the back part, the middle tube and the end cap. And the moderator is going to be 40mm in diameter and 160mm long, which is just a little larger than the standard FX one. Now the way I make these moderators is that I make them so that they screw together. There's no glue or anything like that, and if we need to take one apart anytime we can just unscrew the end caps and it should come apart nicely. So I've got my drawing off to one side and let's begin. Okay, so here we are back over at the lathe. And all I've done to the aluminium tube is cut it to length. It's still about 1/4 mil over length at the moment, but we'll be finishing off the length of it shortly. But first, what we're going to be doing is cutting the female thread in this end. Now the thread we're going to be cutting is an M37.5 with a 0.5 pitch. So a very large diameter thread, but with a small pitch. So first of all, we'll bore the internal diameter out, then we'll cut a relief in the end so the thread's got a gutter. So we'll get started. Right, there's the boring done, so we're about 37.05 there, 06, which gives us a little clearance for the thread. So now we'll go in and cut the undercut, or the thread gutter. That's done like so. Right, there's the thread cutter put in, so we're ready to cut our threads. Before we do, I'll just put a chamfer on this end. Okay, so I've got my tool all set up with a threading bit in it and we're ready to cut the thread. The lathe's set to cut 0.5mm pitch threads, so we're ready to get started. What I always do is I always cut both the female threads first, then when the female threads are cut I can just make the males to suit. So let's get started. Okay then, that's the threads all cut. They look good. So now that the threads are cut, we can polish them up using some Scotch-Brite, and then we can start work on the front cap, which also has a female thread in it. Okay, so next is the front cap. I've already mounted it in the lathe, faced the end off and drilled a 5mm hole all the way through. What we're going to have to do next is bore all of this aluminium out so we end up with sort of a cup-shaped part. We'll drill through with a large diameter drill bit now, just to about 4mm from the face. Then we'll bore it out and put the female thread in there. Right then, so we've got all the middle bored out, it's bored to diameter, and there's a little stop in the back there. So this is obviously the front cap. What I'll do is I'll make a dowel ring baffle that goes in the inside there with a hole in it, and that will help us with the silencing effect. It'll become clearer as we get further into the build, but for now the threads are ready to go in. Now I won't bother showing you it again as it's identical to the last piece we made. So I'll get these cut and I'll bring you back when we're starting the back cap. Okay, so we're working on the back cap now. And this is the part with a 1/2" UNF threaded in it so that we can thread it onto the barrel. What I've done is I've got my piece of stock in the lathe, I've faced it and I've put a 6mm pilot hole through it. We're going to open that up to 11.5, which is tapping size for 1/2" UNF. Then we'll run a tap through it and it's ready to be put on the mandrel. I'll explain a little more about the mandrel in a minute. Right, and there we have it. It's tapped, ready to accept a 1/2 inch UNF mandrel. So you can go ahead and take it out the lathe now. Okay, well at this stage I just wanted to talk about the order in which we do things, why we do them the way we do. So you saw first we cut both the female threads, these ones in here. The order of these isn't important, but it is important that we cut the female threads first. Next we went over to the lathe and made the back piece. We threaded it 1/2 inch UNF, so it's now ready to be mounted onto the mandrel. So what we'll do is, this is a 1/2 inch UNF mandrel. What we'll do is get this running true in the lathe, then when it's running true we'll mount the back piece of the moderator. We'll screw it on like so, then we'll do all further work along this axis. This just ensures that the moderator is always aligned with the 1/2 inch UNF, and just doing it this way ensures concentricity with the barrel. As long as the 1/2 inch UNF is cut along the axis of the barrel, we should not see any clipping problems. So we'll just turn 10mm off the diameter, then we'll put the threads on, screw the tube section on, then put some threads on here. I'll show you how we do that in a minute. Okay, so I've got the mandrel running nice and true in the lathe now. That's a 0.01mm clock there. As you can see, probably got about 5 microns of run out there, if that. So that's plenty good enough for a moderator. So what I'll do now is I'll screw on the back cap and we'll start turning. Okay, so here we are with the back cap. Now it's turned to length. It's turned oversized on the diameter. We'll clean that up when we do the whole mod. And we've got the major diameter of the thread cut. Since we're doing a 37.5 by 0.5 pitch thread, it's nice and simple to work out. The 37.5 is the major diameter, the 0.5 is the pitch, then you can just do your normal thread calculations from that. When I cut these threads, I like to give both the male and the female a little bit of clearance. Typically the sort of general rule of thumb that I use is 10% of the pitch. So in this instance it's a 0.5mm pitch, so I've given both the male and the female thread 0.05mm of clearance. I find that works for me, but you could obviously go more or less depending on your applications. So I've touched off the tool on the diameter and we're ready to cut the thread. For anyone that's wondering, the thread depth on the diameter, i.e. both sides of the thread, is about 0.55mm. And that's obviously taking into consideration the clearance that each part has been given. So that's what I do with my DRO. I zero it on the face here, then cut the thread 90% of the way, and then test the female thread and just do the last 10%, a very, very light cut at a time. So let's get started. Right, so I've done the last couple passes off camera because you can't really see much when my hands are all in the way. But there we go. Screws on nicely. A little bit of clearance in the threads, but not too much. Because it's being anodised, I can't make the threads too tight, as when you anodise something it slightly grows. So I like to leave the threads with just a hair of play in them. But there it is. So I'll give them threads a good clean out now with a toothbrush and some isopropyl alcohol, and then we'll start cutting the male thread on this end. Okay, so we've got the tube mounted on the arbor here. What we've done is screwed that on nice and tight. What we want to do is work off this face forwards, so we know that the moderator is always going to be concentric with the 1/2 inch UNF at the back here. Without working off a datum, there's always a chance that the parts are going to be eccentric from the axis of the 1/2 inch UNF. Doing it this way always ensures that the axis of the moderator is aligned. So we've got to cut a thread on this end, and obviously we can't do it unsupported in the lathe like this. If we were to machine this without any support, there'd be an awful lot of chatter and we wouldn't be able to get a nice finish on the threads. Because the threads are so fine, it's important to get a good finish on them. A rough thread will make assembling and disassembling the moderator extremely difficult, and you might even end up damaging the threads and no longer be able to screw it all together. So to combat this, what I've done is I've turned up this little black Delrin plug. I've also machined a bore in here. The finish on this bore isn't super important, but it has to fit quite closely with this little Delrin cap. What we do is put the Delrin cap in the end there. It's a piston fit. We'll get a centre in that middle, get a tailstock support, so we'll be nice and supported as we cut the threads. Right, so let's get started. Right, and that's the general setup. Now, as we take cuts across the face and cut the thread, it'll be nice and supported with the tailstock, and we shouldn't get so much chatter. Now, when I prepared the stock, I already cut it to length, but we'll just take a facing cut on this end to determine our zero. Right, now that we've found our zero, we can go ahead and prepare the material for the threads. Okay, so like with the back cap, what you just saw me do there was turn the male portion of the thread. We've still got to obviously wind the threads on, but it's ready to accept those threads. We've got our front cap here, and once this goes on, we'll be able to take the Delrin plug out and just use this front piece and put a new centre in it and make sure everything's alright. Right, so let's get started. Right, so what you just saw me do there was cut all the threads and give them a good polish. Used the Scotch-Brite like I did on the back cap here, and the front cap now screws on nicely. It's the same fit as the other one, went to the same thread depth. Just a hair of play in the threads. As I said before, the little bit of play is to account for any growth during the anodising process. The first couple of mods I made like this, I made the threads sort of like a engineering fit, you'd call it. The threads had no play in them, and they just screwed on very tightly. After anodising, the threads were a pain to get on, and I sort of decided it wasn't a good idea to do it like that. So having the threads a little looser just helps with the assembly and disassembly process of the moderators. They don't get taken apart every 5 minutes, but it's just good if you want to clean the internals. If you can't get a moderator apart, it's always going to be a pain to clean. Right, so we're almost done. We're just a little oversized on our length, but that's alright, we can get the centre in it and turn the face down to the correct length. Then we can do a finishing pass on the outside. So let's get started on that. So there's a good close-up of the threads. As you can see, nice and fine. The reason I use such fine threads is because the larger the pitch, the further you have to cut the threads in. This leads to more weight and limits the amount of material you can take out the inside. I could of course do partial threads. I don't really like partial threads, I'd much rather have a full thread profile. I think it's just a nicer way to do it. And another thing about the turning of the threads, technically this is a bit of a cheating way to do it. When we have our cap in the front there, I should really turn a true spot on the moderator and put a steady rest on. But because this isn't a super precise procedure, I don't see the need to. Adds extra steps and extra time to the job. We do give a generous amount of clearance for the pellet anyway, so it's not a problem. However, if you wanted to do it the proper engineering way, you'd put the cap in the end there, turn a true spot on the OD, then set up your steady rest. Then you could take out the tailstock support and just cut the threads normally. Right, So let's get the threads cleaned up nicely, get the front cap on, and then we'll start turning the outer profile of the moderator. Okay, now the front cap's on. We've got a centre in the end and it's supported by the tailstock, so we're free to cut it nice and easily. What we've got to do is take the OD down to 40mm, that's my nominal size, put some chamfers on the ends and finish the face. So it's going to be a lot of plain turning. I'm not sure if I'll show you it all, I'll probably just either speed it up or cut it out. The other thing I want to mention is because this is a hollow tube, there's going to be an awful lot of resonance when we're turning it. This doesn't matter for the roughing passes, but the finishing pass we'll put the lathe on slow and just do a nice fine feed across the entire moderator. Right, I don't know how well the camera's going to pick that up, but we've got a fairly fine finish on there now. Now, it's not the final finish. What we've got to do now is slow down the lathe and take the final cut. I won't bother showing you the final cut, it's rather boring. Okay, that's pretty much a moderator blank made. It's all to length, to diameter, and it's got the chamfer on the front and the chamfer on the back. It's got none of the features that I want to put in it yet, and it's still awful heavy, but it's coming along nice. Final operation to do while it's set up like it is to drill the centre out. Now it's only a pilot drill in the end there for the minute, and we've got to recut it on centre. Then what I'll do is I'll separate all the segments and just put a 45 on each edge. As you can see now, it's turned as one piece, so you can't really see the joins, and I'll take it apart, put a 45 on each end. Right, so there's the hole in the centre cut. As I mentioned before, what we did was we went through with a 8mm end mill to get the hole cut on centre. Then we went through with just a 9mm drill bit. Now that sounds a bit large, but what I do is I put a Delrin insert in the inside of the moderator, which is calibre specific. So 9mm is a clearance for a 2.5 pellet, and what we'll do is we'll just choke it down for a 177 pellet. It just means that I can just swap the ends if I decide to swap the calibre of the moderator. So that's why we do that. And for anyone wondering why we drill it out with an end mill first, it's because the hole we cut in the centre as a pilot when we bored out the end cap won't be in the same axis as the 1/2 inch UNF. So what we did was we re-established the axis by using an end mill, as the end mill won't follow the hole that's already there. It will cut its own hole, whereas a drill bit will always follow the hole that's already there. So we recut the centre and then went through with a 9mm drill bit. Right, that's going to be about it for this one, guys. Just part one, and what we have there is a moderator blank essentially. I haven't decided what features I'm going to put on it yet. I'll probably do some notches around the outside, maybe a little something fancy at the back, but I really haven't decided yet. So that's going to do it for this one, and I'll update you as the project goes on. So thanks for watching, guys, and I'll see you in the next one.